Hey everyone, hope you've been having a great time at the conference so far. My name is Arsh Sharma, and my session is going to be about making DevOps friendlier for developers. So, before I start this talk, I want to catch you up all on what the story has been till now, like before microservices, cloud, and all the fancy stuff related to DevOps started coming into picture, where we were. So, earlier, people who built applications, people who wrote application code like developers were different from people who packaged up the application, which were application builders. But Docker popularized the use of containers, and that sort of led us to ask the question that, hey, now the developer can themselves package the application in a container. So these two kind of people got merged, and basically application building got shifted left. Shifted left means became a responsibility of the developers. Now, this led to teams which could iterate much more faster because every time you know that there's a dependency on someone and task has to go from one team to the other, there is a delay. But when you sort of merge those kind of teams, you sort of skip that delay, and this is how we started, shipping code more faster, and agile culture came to be the norm in the industry. But this was still separated from the ops people whose primary responsibility still was like managing clusters and doing deployments and all the infrastructure side of things. So developers still sort of were not self-sufficient in a sense because they had to rely on ops people. But then came DevOps. So DevOps, the idea was to make developers more independent. The idea was that the dependency for developers on other people should reduce so that we are able to ship features and bug fixes much more faster. So the whole goal was that the ops team now sets up processes which developers can rely on to be self-sufficient. And this is where things started to get tricky because we sort of agreed upon two processes, which were CI pipelines, CI/CD pipelines, and staging environments. But these processes didn't exactly solve what they set out to. Let's see how things changed for developers with these processes. The problem with both these processes was that development still took place in an environment which was nothing like production. So in production, you have all these clusters and Kubernetes running. But when you're developing, you're still developing locally in your editor and bringing up services locally. Or even if you went the extra step and ran containers, everything was not exactly like it would be in production. So let's say whenever there's a bug in the production environment and now you have to replicate that bug locally, developers would call upon ops people and try to spin up local Kubernetes clusters and do all of that. But even then it's tough because you can use Minikube or Kind or something like that, but you can never get the exact same thing you were getting in production locally. So CI/CD pipelines and staging environments have their use. They help you ship code better and faster, but still the use does not come into picture when the developer is writing code. That is, they are far from developer. A developer would have to commit and push their changes for CI pipelines to come into picture, and same for staging environments. You would have to wait for accesses and a build to complete, and then these things come into picture. But when you're writing code, it's just you and your local environment, which is problematic, and which leads to the feedback loop. The outer feedback loop got simplified because of CI/CD pipelines and staging environments. But the inner feedback loop, which is when you writing code and seeing your changes, that became longer because now you saw your changes locally on your laptop as you coded them out, but you still weren't sure how they would look in production because for that you would have to commit and build them and all that sort of thing. Similarly, for ops people also, things did not get that easy, right? Because now, like we said, if there was a bug in production and that had to be replicated locally, ops people would have to configure environments for each developer so that they can now replicate that bug. And these environments weren't replicable. Sure, you could use something like Terraform to have a standard thing spin up, but that's just for your infrastructure, right? Not for your application. So developers weren't that happy, ops people weren't that happy. How do we fix this is the inevitable question. To that, I think the best solution I have found is cloud dev environments. And what these dev environments do, we'll soon see in a demo. But the whole idea is that if everything is happening in the cloud, it's production is there, staging environments are there, CI/CD pipelines are there. So why shouldn't your dev environments live there too? Because we as an industry have always agreed on the fact that development should happen in an exactly production-like environment. And if that's the case, then why haven't we been moving close towards it? Developers should not have to rely on ops and infrastructure people every time they need such an environment. And this is why we came up with a solution which was Octato CLI, which is a completely open source project, and this is the problem it aims to solve. The way this problem is solved is that the operations team configures an Octato manifest, which is just like a one-time process, and this Octato manifest contains all the instructions required to spin up a dev environment. Now, that includes how to deploy your application, something which ops people would have to spend synchronous calls with developers to do that. Now all of that is like in a one configuration file, and it's easily replicable and reproducible. So what happens is the dev environment gets deployed in a Kubernetes cluster. So your application and all the microservices are deployed to a cluster, and then a two-way file synchronization service is set up. So what this means is that the code you write gets synced with the code running in the cluster. So this way you are able to see all your changes as soon as you make them, and you get live feedback. And that feedback is in a production-like environment. It is so you know that whenever you like build it or push it, nothing will fall apart, right? And even if like, let's say there are some bugs, you catch them early on, or if there are already existing bugs, then you're able to replicate them because this environment is exactly like the environment which is there in production. So that was the idea. Like, to make it super clear, I'm going to show you a demo of how this works. And I'm going to be using this simple application, which is a movies application, which is a movies rental application. The source code for this is at github/octato/movies. I have it already cloned, and I have Octato CLI installed. And with Octato CLI, all you have to do is like set a context, which is basically the Kubernetes cluster you want to use and deploy to. I'm using Octato Cloud, but you can use any cluster. Like, it works with AWS, Google Cloud, any vanilla Kubernetes cluster. And once you do that, all you have to do is run Octato up. It's one single command. And this command uses this configuration file, which I was talking to you about, which the ops people said. It's one-time configuration. It tells how to build like all the microservices. So let's say the front-end microservice, the context for building that is in the front-end folder, and there it uses all the existing Docker files there are, and then how you deploy all the stuff you need using Helm. And then there's a dev section, which tells how the development for these microservices should happen, like what folders should be synced, and all port forwarding stuff is here. So let's wait for the deployment to complete. Once the deployment is complete, Octato will prompt you to choose which one of your microservices you want to develop. Let's just keep it simple in this video and make a change on the front end. So I'll choose front end. But the beauty of this approach is that all of these microservices are now deployed to the cloud and are working together. So let's say if you personally wanted to bring up this application, you as a developer would have to bring each of these services up individually. Whereas with this approach, all of them are up and deployed in one single command. So once you select which service you want to develop, what happens is there is a container replacement step. The container running in the cluster gets replaced by a dev container. And what's special about this dev container is that whatever code we write on our local machine gets synced with the code running in the dev container. So that way, any change we make here will be reflected live in that environment, which is running in the cluster. So that's how you are able to like develop in a production-like environment. And to see this, like you see, we have access to the terminal in that dev container. And we also have access to endpoints where we can visit our application. So this is the endpoint where the front end lives. But like I said, this is running in the cluster, running in the cloud cluster, but everything is sort of like how you would be developing locally, because it is still at the end of the day like development which is happening on your machine, right? So to do that, you will have to first run yarn to install all the dependencies. So let's just go back to our IDE and run yarn like you would locally. So all of this is like locally, but all of this is happening in the cloud. And then you run yarn start. And what that basically does is start the server where the application is. And if we hit refresh now, we see that our application is up and running. Now, like I said, this is just the application running, and whatever code you write will get synced. So let's also test that out. And I have this code already written. I'll just uncomment it, which is basically a discount coupon. And if we go back here, we see that this thing appears, which is the code we just wrote. If we comment it again, go back, hit refresh, it's gone. So I hope you can now see the beauty of this approach, how whatever code we write gets synced, and how the inner dev cycle is now reduced and like its dependencies on like things like CI pipelines and waiting for builds to complete or waiting for ops people to set up environments has reduced significantly, and developers now are much more independent and much more confident when writing code, because you know that if that code works here, it will work in production, it will work in your CI pipelines and your staging environments. So that's the whole idea, that's the whole goal, that we simplify DevOps by giving developers all the tools to be self-sufficient, and the ops people only have to be responsible for setting up and maintaining these tools. Going back to the slides, just a recap of all the benefits of this approach is like developers can now get to the code writing phase by skipping all the configuration. Like you saw, we only needed to run octet-op. We did not need to bring up front end by writing yarn start, and then bring up the back end and then configure the database and all that sort of microservices stuff. All of that was skipped. All you had to do was run one single command, octet-op. And the environment was exactly like production. The feedback is instantaneous, so as soon as you hit save, you get to see your results. Whereas with a CI pipeline, you would have to wait a few minutes for all the building and deployment to happen. So the goal is that if you are developing for the cloud, then you have to develop in the cloud as well, because that is how you're going to make less mistakes and ship applications which are much more smoother and much more cloud native in nature. Thanks, this was it. Thanks for watching. If you have any questions, feel free to reach out to me on Twitter at @rinkiakedad, and I hope you have a fun conference ahead.